Hi everyone, Chapter 4 Chemical Bonding 4.1 Lewis Structure Part 2. In this part, I will show you how to draw the Lewis structure involving the molecule with the single bonds, double bonds and triple bonds. And you will need to know the bond length between the atoms and choose the most plausible Lewis structure based on its formal charge. And you also need to know the exceptions to octet rule. There are incomplete octet, expanded octet, and odd number electrons. Lewis structure. We refer to a diagram that shows the bonding between atoms in a molecule and the lone pairs of electrons that may exist in the molecule. How to draw the Lewis structure of a covalent compound? So there are 4 steps to draw the Lewis structure of a covalent compound. Let's see step 1, which is you have to count all valence electrons. Okay, for the example, I'm using NF3. So this is how you calculate the total number of the valence electron in NF3. In a molecule of the NF3, there are only one nitrogen, which is for the nitrogen. Okay, the valence electron is 5. So total for the valence electron nitrogen 5, and for the fluorine, each of the fluorine it has a 7 valence electron, but there are 3 fluorine, so total valence electron for the fluorine is 21, and the total valence electron in NF3 is 26 electrons. In step 2, you have to place the less electronegative atom in the center of skeletal structure. So nitrogen is less electronegative compared to the fluorine, so it is put as a center. In step 3, you have to draw single covalent bond between nitrogen and fluorine. Then you counting the total number of the valence electron, which is for this compound. Now when you complete the 3 covalent bond, the 26 electron, this one you already calculate in the step 1, and then minus to the 6 electron. 6 electron we refer to the bonding electrons, because there are 3 covalent bond. 1 covalent bond equivalent to 2 electrons, so 3 bonding equivalent to 6 electron. So 26 minus to the 6 bonding electrons, and the balance is 20 electron. In step 4, you have to complete the octet for the atoms with the remaining electrons. So means that in the molecule, okay, when you form the 3 bond and then you complete the lone pair on surrounding atom. So each of the fluorine, it has 3 lone pair, 1, 2, 3, which is to make it octet, because fluorine is an octet atom. So there are 2, 4, 6 and 8, including 1 covalent bond. Okay, and same for the other fluorine atom. And when you calculate, okay, again the valence electrons, the 20 minus to the lone pair electrons on all fluorine atom, which is 1 fluorine atom, it has 2, 4, 6, and for the 3 fluorine atom they are 18. So 20 minus to the 18, okay, 20 electron minus to the 18 electron, and the balance is 2 electron. And these 2 electron, okay, you put as a lone pair on nitrogen. So this is a balance of the 2 electrons. So nitrogen is categorized as a octet. Okay, so that's why there are 2, 4, 6, 8 electrons around the nitrogen. So this is a Lewis structure of the NF3. Then you can check whether it is correct or not by calculate the total valence electron. So we know that each of the fluorine atom, around the fluorine atom, it has 8 electrons. So this one, so there are 3 fluorine atom, okay, 8 times 3, 24 electron, plus with the 2 electron adding the lone pair on the nitrogen. So the total is 26 electron. So this is a Lewis structure for the NF3. Okay, let's see how to draw the Lewis structure for the ion, which is we choose here is the ammonium ion NH4+. Okay, step 1, as usual, you have to calculate the total valence electron. Okay, and here when you total nitrogen, hydrogen, okay, because there are 4 hydrogens, so 1 electron times to the 4. But because it is a positive ion with the positive 1, okay, and you have to minus 1 electron. Okay, if the positive ions, you have to minus according how much is charged. So here, okay, it is a 1 positive, so you minus 1 electron, and the total number of the valence electron is 8. Remember to add electrons if the negative charge and minus electrons if positive charge. Next step, okay, this one I combine step 1 and step 2, okay, which is I put atom with the less electronegative at the center, and at the same time I form the single covalent bond with each of the terminal atom, that is hydrogen. So I combine step 2 and step 3. In step 4, okay, you have to complete the octet for the atoms. So for the nitrogen, okay, it is a octet. So you can see that there are 2, 4, 6 and 8 electron. But hydrogen, okay, it is not octet. Okay, it is categorized as octet, but it is duplet. On the maximum electron around hydrogen only can 2 electrons. So please be careful, okay, do not put the lone pair on the hydrogen, because hydrogen is the duplet and it only can have 2 electrons around it. And this is a Lewis structure for the NH4+, okay, because it is positive ion, then you have to complete it with the square bracket and the charge outside the bracket. So you can check this Lewis structure is correct or not. So by calculate the valence electron, total valence electron in H4+, okay, here 2 electrons, okay, each of the covalent bond equivalent to 2 times 4, so 8 electron. So same as you calculated in step 1. Okay, let's see for the negative ion, carbonate ion, CO3 2 minus. Okay, step 1, you have to calculate the total valence electron, and because the charge is 2 negative, so you have here, okay, you have to add electron if negative charge. So because it is 2 negative, that's why you have to add 2 electrons, and the total valence electron is 24. Then here I combine step 2 and step 3, okay, which is I put carbon as a center because it is less electronegative compared to the oxygen, and then form the covalent bond between carbon and all the 3 oxygens. Then, okay, complete the octet for the atoms. Okay, if the central atom not octet, lone pair on the terminal atom is used to form multiple bond with the central atom. So, okay, when you complete the lone pair on the oxygen, okay, so one oxygen, it has 3 lone pair, just like this one. So the total valence electron minus to the bonding electrons 2, 4, 6. So here is 24 minus 6, so 18 electrons. And these 18 electrons, okay, because each of the oxygen, it has 3 lone pair, so total lone pair on 3 oxygen is 18. So here 18 minus 18 electrons, so no more electron, okay, that you have to put at the center. But the carbon is not octet, okay. Carbon, actually it is categorized as an octet, but now the Lewis structure shows that carbon is not octet. So what you have to do is, okay, you see that the statement, if the central atom not octet, lone pair of the terminal atom is used to form the multiple bond with the central atom. So one of the oxygen, okay, let's say this oxygen, it will share one of the lone pair, okay, for the example this one, to form bond with the carbon. So you can see that the double bond is formed between this oxygen and carbon. Now you see that the carbon is octet because, okay, there are 2, 4, 6 and 8 electrons, 2 single bond and 1 double bond. So you can check your Lewis structure by calculating the total valence electron, which is each of the atom has 8 electrons, okay, times 3, so it is 24 electrons, same as you calculating in step 1. Okay, bond length, we refer to the distance between the nuclei of the 2 covalently bonded atoms in a molecule. So this is a diagram, shows how the bond length between the 2 atoms. So this is a nucleus for one atom and this is a nucleus for another atom, and when it form bond between these 2 atoms, okay, you can see that this is the bonding, okay, and bonding, you know, it is the electron. So what happened here is there are repulsions and attractions. The repulsion occur when negative electrons, okay, bonding electrons and bonding electrons, okay, it will cause the repulsions. But the between the negative ion and positive of the nucleus, okay, it will form attractions. So there are repulsions and attractions at the same time. And this one, okay, it will cause the distance between the between these 2 nuclei, okay, that is the distance, okay, and we call it as the bond length. So for the single bond, okay, it has a greater bond, okay, bond length compared to the double bond and triple bond. Okay, the most plausible Lewis structure. Okay, for the example here, I show you the carbon dioxide. Okay, this one is not the Lewis structure because the carbon is not octet. But when the oxygen, each of the oxygen, okay, share the the oxygen, okay, can share the electron to form bond with the carbon, okay, to make it octet. So one of the structure is when this oxygen, okay, it share 2 lone pair to form bond with the carbon, and it end up with the triple bond between the carbon and oxygen, which is oxygen, okay, it only has 1 lone pair because it already using 2 lone pair to form bond with the carbon. So this is the first structure. And the second structure, each of the oxygen, it will share 1 of the lone pair to form bond with the carbon. So for the oxygen at the left side, it share 1 lone pair to form bond with the carbon, so this is a double bond, and same for the other side. So for the carbon dioxide, there are 2 Lewis structure, but which Lewis structure is the most plausible Lewis structure? What is the most plausible Lewis structure actually? The most plausible Lewis structure, we refer to the most stable structure, represent the molecule. Okay, that is the most plausible Lewis structure. Okay, there are one way to determine the most plausible Lewis structure is based on the concept of the formal charge. You have to calculate the formal charge each of the atom in a molecule. So by using this formula, the total number of the valence electron in the free atom, okay, minus to the total number of the non-bonding electrons minus to the half of the total number of bonding electrons. Or you also can use this formula, okay, which is number of the valence electron minus to the number of the lone pair electron and half of the bonding electron. So let's see the formal charge for the carbon dioxide. Okay, for the structure 1, okay, when you calculate the formal charge of each atom in the carbon dioxide, okay, so for the example, okay, calculating formal charge for this oxygen, the oxygen at the left, okay, so there are the total valence electron for the oxygen is 6. Okay, this is a valence electron for the oxygen. Minus to the 6, okay, we refer to the non-bonding electrons. The non-bonding electron we refer to the lone pair electrons. So you can see here there are 6 dots. So minus to 6 plus with the half bonding electron. So this oxygen, it has one bond equivalent to 2 electrons. So in bracket 2, then you will get negative 1. For the oxygen at the right side, okay, with the same formula, 6 valence electron for the oxygen minus the 2 because there are only 2 dots, okay, and plus with the half of the 6 because there are 3 bonding, okay, so 1 bonding equivalent to 2 electrons and 3 bonding equivalent to 6 electron, and the formal charge for the oxygen is positive 1. Okay, so this is positive 1. And for the carbon, okay, valence electron for the carbon is 4. Minus 2, there are no lone pair on carbon, but the bonding electron half times to the 8, okay, because there are 4 bonding around the carbon, 1, 2, 3, 4. So 1 bonding equivalent to 2 electrons, so 4 bonding 8 electron, and the formal charge for the carbon is 0. So this is a formal charge for each atom in the carbon dioxide for the structure 1. And if you calculate the net charge, means that the total formal charge, then you will get 0. So carbon dioxide is neutral. Okay, so that's why the charge for the carbon dioxide is 0. Let's see for the structure 2 with the same formula, then you will get all the atoms in the carbon dioxide has a 0 formal charge. Okay, so by using this chart, okay, higher priority and lower priority, which is the 0 formal charge on all atoms, means that higher priority given to the molecule with the 0 formal charge on all atoms. Okay, and then if the formal charge of all atoms not 0, so you have to choose the one with the smaller formal charge closest to the 0, or negative formal charge are placed on the more electronegative atoms. Okay, so between this structure 1 and structure 2, of course structure 2, okay, is the most plausible Lewis structure. Why? Because it has 0 formal charge on all atoms in carbon dioxide. Okay, let's see the exception to octet rule. Okay, there are 3 incomplete octet, expanded octet, and odd number of electron. Incomplete octet, there are only 3 elements in the periodic table, which is beryllium, boron, and aluminium. These 3 elements, okay, can form incomplete octet. And let's see the example here. Okay, we have the beryllium hydride, systematically named beryllium dihydride. Is an inorganic compound with the chemical formula BeH2, and it is a colorless solid that is insoluble in solvents that do not decompose it, unlike the ionically bonded hydrides of the heavier group 2 elements. Beryllium hydride is covalently bonded, and it needs you to draw the Lewis structure of the beryllium hydride or dihydride, and it also need you to state the type of the exceptions to the octet rule. So as I showed you before, okay, there are 3 exceptions to the octet rule involving the incomplete, expanded, and odd number of electron. So when you draw the Lewis structure, follow the 4 steps that I already teach you, okay, early. Then this is the Lewis structure for the beryllium dihydride, and you can see that around the beryllium, okay, it only has 4 electrons. So it is type of the exceptions, okay, it is incomplete octet. Okay, next. Okay, this is an example of the expanded octet, which is it occurs when the central atom has more than 8 electrons in its valence electron, and usually it involves the non-metal atoms of the 3rd period and beyond, okay, which have the empty 3D subshell. So this is an example SF6. So you can see that if there are more than 4, of course it will form expanded octet, just like SF6. So around sulfur, you can see that there are 2, 4, 6, 8, 10, and 12 electrons around the sulfur. Okay, so this is a Lewis structure for the SF6. Odd number electrons. Okay, some molecules have an odd number of the valence electrons. So this is the example, nitric oxide. So when you calculate, the total valence electrons is 11 electron. Then, okay, you have in the second step, okay, and third step, which is you have, because it only has 2 elements, so you just directly can draw the bonding between the nitrogen and oxygen firstly, and then you calculate the total valence electron after it formed the covalent bond, which is for the nitrogen total 11 minus to the 2, so 9 electrons. Okay, 9 electrons, and then you complete the lone pair on the atom that more electronegative. So here between nitrogen and oxygen, oxygen is more electronegative. Then you complete the lone pair on the oxygen, and then the balance of the valence electron you put on the nitrogen, okay, as a lone pair. So here you can see that the nitrogen has 1 lone electrons. So this is the example of the odd electrons. Okay, so you can see that why oxygen is share one of the lone pair to form bond with the nitrogen, because nitrogen is categorized as the octet. So if the bonding is a single bond, there are only 2, 4, 5 electron around the nitrogen. So use the oxygen, okay, which is it will use the lone pair, its lone pair to form bond with the nitrogen. And now the nitrogens, okay, the total valence electron nitrogen is 2, 4, 6, and 7. So it is not 8, but it is near to the octet. So this is an example of the odd electron. And remember, most of the odd electrons have a central atom from the odd number group, such as group 15 and 17. So this is an example, okay, these 2 examples of the odd number electron.